Okay, welcome back. So this is the Related Rates Lecture Part 3 video. In this video, we're going to do the last example on that handout with the 4 examples. And we're going to go through the steps, the problem-solving steps on that other handout, Related Rates Problem-Solving Steps. So you should have those 2 handouts with you as you watch this video. So the first thing I want you to do is look at steps 1 and 2 on the Related Rates Problem Solving Steps handout. And I want you to pause the video and read this problem and try to draw the picture of what's going on. So pause the video. Okay, so now we're back and you've unpaused. And so I'm going to go through this example. So the first step, I've already read the problem, so now I'm on number 2. I'm going to draw the picture. So we have a boat, a dock, and a rope. Those are the 3 main things. Well, the boat is in some water, so I'll draw the water. There's my boat. There's my dock. And then there's the rope. And so now I'm going to start defining variables, step 3, and labeling things in the picture that are changing. So first of all, what kind of variables, what do I need to represent with a variable? What are the things that are important, that are changing? So the thing that we're asked to find is how fast the boat is approaching the dock when the boat is a certain distance from the dock. So speed is distance divided by time, right? So I need the distance between the boat and the dock to be one of my variables because I'm going to differentiate that distance to get the speed. So in step 3, the first variable, I'm going to let x be the distance between the boat and the dock at time t. Okay. Now, one of the other bits of information we're given is that the rope is being pulled in at a rate of 1 meter per second. So the rate of change of the length of rope between the boat and the dock is 1 meter per second. So we need a variable to represent the length of the rope. So let's let y be the length of the rope at time t. Okay, so now I can start labeling. So the distance x between the boat and the dock, the length of the rope, and also that 1 is the 1 meter that it says the pulley on the dock where the rope is attached, or the rope goes through the pulley on the dock, is 1 meter higher than the bow of the boat. So that's where that 1 comes from. Okay, so now we're at step 4. We're going to state what we're given and what we're asked to find. So I'm going to write given and find. So I am given this rate, the rate at which the length of the rope is changing. It's 1 meter per second. And so according to my picture, the length of the rope is y. So that means dy dt is -1 because the length of the rope is decreasing. As we pull the boat in, that length gets shorter. Okay. And so we're asked to find how fast the boat is approaching the dock when it's 8 meters from the dock. So the distance between the boat and the dock is x. So the rate that we're asked to find is dx dt, and we're asked to find dx dt when x is 8. So when the boat is 8 meters from the dock. Okay, so now we're ready for step 5. We're going to write an equation that relates the quantities that are changing. So what are the quantities that are changing? So we're going to write an equation relating the quantities that are changing. So we look at the derivatives from step 4 to figure out what quantities we need. We need y and we need x because we have a dy dt and we have a dx dt. So we need an x and a y. So I look at the picture and I see there's a right triangle. So the equation that relates y and x is going to come from this right triangle. It's the Pythagorean Theorem. So we can write x squared plus 1 squared equals y squared. So in a lot of problems you'll have a right triangle situation and you'll just use the Pythagorean Theorem. In some other problems you'll need trig functions. But most of them you'll need the Pythagorean Theorem. So now, step 6, we're going to differentiate this. So 2x dx dt plus 0 equals 2y times dy dt. And let's just simplify it a little bit. Isolate the dx dt because that's what we're asked to find. And now we can start plugging things in part 7. So dx dt evaluated at x equals 8 is y over 8 times negative 1. So y is the only thing we don't have. We have x equals 8 and we have dy dt equals negative 1. So what are we going to put in for y? Well, we can use the Pythagorean Theorem again. When x is 8, y is going to be the square root of 8 squared plus 1, or square root of 65. So now we can write square root of 65 over 8 times negative 1. So negative square root of 65 over 8 is dx dt when x is 8. So now we are asked for how fast the boat is approaching the dock, and we got a negative answer. We got a negative answer because dx dt is the rate of change of the distance between the boat and the dock. And it makes sense that it's negative because the boat is approaching the dock. But the way the question is phrased, they want to know how fast is the boat approaching the dock. They want to know the speed of the boat, not the rate of change of that distance. So the way we're going to answer the question is we're going to say the boat approaches the dock at a rate of positive square root of 65 over 8, or 1.01 meters per second. So when you're answering the questions in WebAssign, make sure that you answer the question appropriately. So in this case, I did get dx dt was negative, which is fine. It's not incorrect. But I had to answer the question with a positive number because of the way the question was phrased. Okay, That's the final video, and I hope you can use these to understand and to get your homework done over the break. So have a wonderful spring break, and I will be checking my email and helping you out if you need it as you work on these assignments. And I'll see you in April.